Hello everyone. This video is about the Knewton Alta assignment section 2.2 part 3 called Equations of Lines, and in this video I'm just going to be going over a version of this particular Knewton Alta assignment. Now please understand that the questions I'm going to be seeing in this video may not be the exact same questions you see when you work on the assignment yourself, but the objectives are going to be the same, so the questions should be similar. And I'm hoping that watching me work on them will help you in some way when you work on them yourself. Alright, so here's the assignment page. Again, you will not see the words preview of, you'll just see the title. Got your mastery bar telling you how far along you've gotten. You can see all your objectives. Now this is going to be a long one. There are 6 objectives. All right, 4 in one topic and then 2 in another. Okay. So might be a bit this video. And then underneath the current objective, right, there's a question related to that objective. And then at the bottom of every question, you should be seeing a couple buttons. There's a feedback button where you can send feedback to Knewton if you see something wrong with a question, like a typo, or something wrong with how they answer, or something like that. If it's something that's clearly incorrect about the question, and hopefully they'll get back to you soon and fix the problem. You will not see the instructor cheat button. This is for me only. You will see the more instruction button, which can be very useful if you are struggling with a particular objective or on a particular question. Try clicking on the more instruction button. It'll take you to a page where there's some reading to do or videos to watch, or both, and then you'll have questions related to that instruction, and if you get those correct, it will move you through the assignment just like getting normal questions correct. So you can, if you wish, for every new question, click on more instruction and work on the questions they provide there with the instruction, and there's nothing wrong with that. Alright, so our first question is on the objective, understand the relationship between the slope and the y-intercept of a line and its equation. Alright, so here we're asked to find the equation of the line, which has slope 7 and y-intercept 2. And give your answer in the form y equals m times x plus b. Alright, so let me talk about slope of a line first. Alright, so I got some paper here. And I'm just going to give my little talk about slope in general, and then hopefully that'll be a useful page for the rest of the video. Alright, so the slope of a line it's a number. Alright, the slope of a line is a number. It's a number that tells us how the y-coordinate will change when the x-coordinate is increased by 1. Or at least that's one way to interpret it. I'll show you a couple different interpretations of slope. A number that indicates how the y-coordinate, or the output, sometimes people refer to y-coordinates as outputs, how the y-coordinate will change if the x-coordinate is increased by 1 unit, or if the input, sometimes x-coordinates are referred to as inputs. I almost wrote input there. X-coordinate, COO, is increased by 1 unit. Right. So for example, now they're telling us, the slope of this line is positive 7. Now, instead of writing out the word slope all the time, very often a lowercase m is used. It's from the French monter, to go up, to rise. And we'll talk about rise and run and all this in a second, but m equals 7, this means the same thing as the slope of the line is 7. Alright, so what does that mean? Alright, well that means the following. If you go from one point on the graph, right, they told us the y-intercept, which is a point on the graph, is at 2, right, or the point 0, 2. What this means is that if we increase the x-coordinate by 1, let's say increase x by 1, then the y-coordinate should go up by 7. That's what that means. Alright, because it's a positive 7. Alright, if the slope were negative 7, if you increase x by 1, then the y-coordinate would decrease by 7. Alright, positive slopes, your y-coordinate's increasing when you increase x by 1. Negative slopes, your y-coordinate's decreasing when you increase x by 1. So another point on the graph, right, another point on this line using the slope would be the following. Again, I know 0, 2, I know the y-intercept is 2. I increase x by 1 unit, so 1 for the x-coordinate. The y-coordinate would have to increase by 7 because, they said the slope was 7. That's what slope means. Right, so 9, sorry. I wrote the number 7, but 2 plus 7 is 9. Alright, let's see how the graph of the line would look. Alright, again, just a very rough sketch on the xy plane. Here's 0, 2, and then I go to the right 1 unit, and if you go to the right 1 unit, increase x by 1, you have to go up 7 for this particular line because they told us the slope was 7. So from this point up 1, 2, 3, 4, 5, 6, 7, there's 9, and there's the point 1, 9. Right, and the rest of the line, right, it's a line, so I only need 2 points to draw it, and I guess I should have pulled out a ruler, but there's the rest of the line that they're talking about. Alright, so what you're going to notice too is that, lines with positive slopes will be going up as you go to the right. If you increase x by 1 unit, you're going to be going up. So to the right and up is how those lines will go. Alright, so I'll just put that here. Lines with positive slopes will be like this line here. Lines with positive slope will be going, up to the right somehow. Okay. Alright. Now for another example. Alright. How about what if I had a negative slope? Alright. So what if I told you the slope was negative 3, right, or m equals -3. And I gave you a point on the line, right? You need to be able to determine a line, you need either 2 points, or the slope and a point on the line, right? Like the y-intercept in the previous example. So again, I'm just making this one up. All right, so say the slope is -3, and you know, the point 1, 6 is on the line. All right, so if I started drawing this, you know, here's 1 on the x, 6 on the y. There's 1, 6. Right. Now, because the slope is -3, if we increase x by 1, y, right, the y-coordinate will decrease by 3. Right? A negative slope means if I increase the x-coordinate by 1, we're going to go down that many units. So I say decrease y by 3. So another point on a line like this would be 2, right, increase x by 1, and then decrease the y-coordinate by 3. 6 minus 3 is 3. So increase x by 1, go to 2 on the x-axis, and then from this point, you know, decrease y by 3. We're at the point 2, 3, and now that I have 2 points, we can determine this line. And there's the line that goes through those 2 points. Right, a line through the point 1, 6, 2, 3. This has a slope of -3. Right. Every time x is increased, you know, I'll put other points. Another point on this line. Let's increase x by 1, decrease y by 3. Right, 3, 0 would be on the line. That would be the x-intercept. Another point would be 4, -3. Right, you know, 4. Here's -3. Right, 4, -3 would be on the line. 5, -6 would be on the line. You know, it works throughout the entire line. You increase x by 1, and the slope tells you how much the y-coordinate changes when you increase the x value by 1. Right. And this is going to be the case for any negative sloped line. It will be going down to the right. So let me write that here. So any line with a negative slope is going to look like this in general. It might be going down to the right, kind of like that line there. All right, now what if the slope isn't positive, and what if the slope isn't negative either? All right, well, that would be a slope of 0. All right. 0 is not positive or negative. Let's take a look at that. So another example. What if the slope was 0? M equals 0. So again, what this means is that if I'm on this line, if I increase x by 1, I don't do anything to y, right? I increase or decrease y by 0. So if the slope is 0, and let's say a point on, again, I'm just making this up, just as an example, point on a line, let's say the point 5, 4 is on this line. All right. 5, 4. Right, so there's a point on the line. And then again, the slope being 0, you know, if I increase x by 1, I'll just say plus 1 now, we're going to increase y by 0, right? Whatever the slope is. Once more, slope tells you how much y will change if x changes by 1, if x increases by 1. So another point on this line would be 6, 4, and 7, 4, and 8, 4, right? The y-coordinate is always 4. So 6, 4, 7, 4, 8, 4. And what do you get here? Right, a line with a slope of 0 is just a horizontal line. And I'll write that here. Goes straight to the left and right. It's parallel to the x-axis. So, any line with 0 slope is just a horizontal line. Right. It's parallel to the x-axis. Alright, now what about vertical lines? We see positive slope lines. Right, positive slope lines go up to the right. Negative sloped lines go down to the right. Slopes of 0, lines with slopes of 0 are horizontal. They don't go up or down at all. What about vertical lines? All right, now this is the tricky part. I find that most people find this tricky the first time they see it. A vertical line, I'll just make the note here. Vertical lines have an undefined slope. There's no number attached to it. It's undefined. Because if you think about it, let me draw a vertical line here. Now a vertical line would be parallel to the y-axis. So say here's 1, 2, 3. Say there's 3, 0, and 3, 1, 3, 2, 3, 3. Basically every point has the same x-coordinate. Right, it's going straight up and down. See, so to get from one point to the next, you got 3, 0, you got 3, 1, you got 3, 2. See how the x-coordinates on a vertical line do not change. So x-coordinates, don't change on a vertical line, meaning they can't be increased by 1. They can't be increased by 1. So the definition of slope that I told you earlier doesn't apply. All right, remember, slope is a number that tells you how the y-coordinate will change if, put that here, if the x-coordinate is increased by 1 unit. But if the x-coordinate doesn't change at all, then that definition doesn't apply. All right, so they would say that slope m is undefined. Right, there's no number associated with a slope of a vertical line, right, because x can't change from point to point. All right, so that was one interpretation of slope, one way to see it. Now, an alternate interpretation of slope that you may have seen more often is rise over run, vertical change over horizontal change. Slope equals rise over run. Or, vertical change divided by horizontal change. Which would be denoted as, delta y divided by delta x, right? This little triangle symbol is delta. It means change in, right? The little delta symbol. But yeah, you may have seen this before. So yeah. And then here's the slope formula, right? Given 2 points, right? Given 2 points on a line, say x1, y1, and x2, y2, the slope of that line is the following. M equals, and again, it's the change in the y-coordinates. So just subtract the y-coordinates. So say, I like doing second minus first. y2 minus y1. Just subtract them in some order. And then whatever order you subtracted the y-coordinates in, you must then subtract the x-coordinates in the same order. Alright, so if I did y2 minus y1 for the numerator, I need to do x2 minus x1. You can't do x1 minus x2. Those must be taken in the same order. And this is our little slope formula. Right. So for instance, say the point 0, 2 and 1, 9 are on a line, like in my first example to you. Then the slope is, again, the numerator, just take the change in the y-coordinates, 9 minus 2, divided by the denominator, take the change in the x-coordinates, 1 minus 0, that's 7, divided by 1, which is 7. Alright, in that first equation, right, that first line, we did say the slope was 7. Alright, and this also tells us, this rise over run interpretation, tells us another way to move around a line. Right? Instead of increasing x by 1 all the time, right? What I was doing earlier was I was increasing x by 1 and then increasing the y-coordinate or decreasing based on the slope. Another example is, if I have a slope of, say a fractional slope, say 2/3. So you can think of the numerator as the vertical change, right? A change in y. And if it's positive, you increase. If it's negative, you decrease. And you can think of the denominator as the change in x if you wish. And let's say there's a point on this line, and again I'm just making this up. The point, say the point 1, 2 is on the line. Right. So 1, 2. Now, I could use the alternate version of that first version of slope. Right? I'll say here are some other points on this line. If I increase, using my original interpretation of slope, if I increase x by 1, so I go from 1 to 2, I'd have to increase y by 2/3. So 2 2/3 would be the y-coordinate, which I don't really like all that much. But here's 2, and then, I go up to 2 2/3, right? Which is just somewhere between 2 and 3, so like there maybe. But again, I don't like doing that because it's hard to eyeball what 2/3 is, or 1/3, or maybe 1/5 or something. It's hard to eyeball fractions sometimes. So instead, I can go back and just look at the numerator and denominator separately. And the numerator is a positive 2, so that means I increase y by 2. And the denominator, the run, is a positive 3, so I'll increase x by 3, and another point on this line would be 4, 4. Alright, 1 plus 3, 2 plus 2. And 4, 4, right, should be on this line as well. and then I just keep doing that. Keep adding 3 to the x-coordinate, 2 to the y-coordinate. You'd have 7, 6 is also on the line. 3 added to the x-coordinate, 2 added to the y-coordinate. Okay, and you're getting all these points on this line here, and they should all fall on the same line. I mean, if you're using the slope properly. And again, it's going up to the right because you had a positive slope here. Okay, so that's another way to interpret slope: rise over run, and you can use that to move around lines as well. All right, now this question we were given. All right, now finally going back to the question. They're asking us to write the equation of a line in this form here. Now, they're asking us to write it in the form y equals m times x plus b. This is called slope-intercept form. Right, m is the slope of the line, the coefficient of x, and b, this b here, is just the y-coordinate of the y-intercept, or sometimes just referred to as the y-intercept. Right, 0 comma b would be on the line. Right, you can see that if x were 0, this mx term would disappear and you'd have y equals b. Right. So finally, back to our, I just wanted to get that discussion of slope out of the way so it'll help us for the rest of the video. But back to our question, they say the slope is 7 and the y-intercept is 2. So they gave you m and they gave you b. So the equation for the line would be y equals 7x plus 2. All right. So an example, right, when they told us the slope was 7 and the y-intercept, the b, was 2, the equation for all the points on the line would be y equals 7x plus 2. And let's see if that works. All right. Let me go all the way back. Well, not all the way back. That was this example here. Right, the y-intercept was 2, the slope was 7. Would the point 1, 9 be on this? Right, let's see. If x, let's make a table. Right, if x were 1, 7 times 1 is 7 plus 2 is 9. So that checks out. How about, right, what did I say? Okay, let's see. What else would be on this line? What did I say earlier? Right, if we increase x by 1, y should increase by 7. Let's see, 2. 7 times 2 is 14, plus 2 is 16. That should be on the line, right? Increase x by 1, y increases by 7. 23 should be on the line, right? 21 plus 2. This all works with this equation, all these points. And it also matches my interpretation of slope at the very beginning. So that's good. Y equals 7x plus 2. Let's put that in. Now they already have the y equals part, so I don't have to type y equals again. Just put the right side, 7x plus 2. And that should be good. All right, so that was a long way of getting around going to this. Really, it was a pretty easy question to answer, actually, if you knew what slope-intercept form of a line was. So yeah, so if you know the slope of a line and you know the y-intercept, you should be able to write the equation of a line pretty quickly. Right, that describes all the points. Alright, so moving on. And we'll get into other forms of equations in the rest of the video here. But for right now, we got the slope-intercept form. Alright, so here is find the slope of a line given 2 points. Alright, so I showed you that slope formula, right? The change in y divided by the change in x. Okay, so it's just the line L, some line, goes through points 9, 8, and negative 9, 7. Find the slope of this line. And just enter your answer as a simplified improper fraction. If necessary, do not include m equals, right? So just write the number. Alright, so back here, I'll pull up some paper. We got the line goes through points 9, 8, and negative 9, 7. Now, you don't have to do what I'm about to do here, but you can just make a little sketch of, what would this line kind of look like. I'm going to make this very rough though. 9 on the x, 8 on the y, right? I'm not even dotting, I'm not even making little dashes. I'm just saying, 9, 8 would be somewhere in quadrant 1. Negative 9, 7. Negative 9 on the x. Now 7 on, just make sure numbers are in their proper places. 7 would be below 8. It's over here. And then the line would be like this, which is going up to the right. So it should have a positive slope. That's the only reason I would draw a picture like this, just to make sure I know that when I calculate this slope, it should be positive. So once again, very easy. Numerator, subtract the y coordinates, 7 minus 8. 7 minus 8. And again, I like doing right minus left, second minus first. And then in the denominator, subtract the x coordinates in the same order. Okay, so I'm going to do second minus first again, negative 9 minus 9. Alright, so the numerator, 7 minus 8, that's negative 1. And then negative 9 minus 9 is negative 18. And a negative divided by a negative is positive. Right? Positive 1/18. And that's what we're going to enter. Right. So again, all this means is if I increase if I increase x by 18, I have to increase y by 1. Right? So right 18, up 1, which is what we're seeing here in my graph. Right? Or if I increase x by 1, I have to increase y by 1/18. Right? You can think of it that way too. But the answer is 1/18. Right? And that's all, right? Don't put m equals. They don't want the m equals. Great. All right, and please read through your answer explanations. I forgot to mention that in the first question. Whether you're right or wrong, just to see, make sure you understand why you got something right or wrong, so you can fix things in the future. Next is on, so back to the relationship between slope, y-intercept, and the equation of the line. So here we're asked to find the slope of the following line. Alright, now this is in that form. Alright, this is in that y equals mx plus b form. Right, y equals, the equation we're given is y equals negative 4x minus 2. Right, so again, you got y equals, y is alone, equals, and then some number times x plus some number. This is exactly in this slope-intercept form. So the slope, again, the slope is just the coefficient of x, the number attached to x. The slope of this line would be negative 4. And that's all they wanted, the slope. The y-intercept, that would be the point 0, negative 2, right? The b here is negative 2, right? It's plus b, minus 2 means plus negative 2. Okay, but they only wanted the slope. So very, very simple, again. So negative 4, right? And just type the number. Just type the number. Great. And pretty easy, that one, I think. Moving on. Now, find the y-intercept of this line. Again, very simple. It's already in this slope-intercept form. And if an equation is not in slope-intercept form, just solve for y. Get y alone, and then simplify the other side by combine like terms, use distributive property, whatever. See how there's no parentheses on the other side, right? Get rid of parentheses using the distributive property, combine like terms. Get y alone. And then you'll have it in slope-intercept form. It's that simple. So here, the slope is again -4, and the y-intercept, now they're going to say is just the number, they do ask us to give an ordered pair. Good. So remember, when x is 0, you're on the y-axis. So when x is 0, you get y equals 5, right? You know, the plus 5 there. And this is what they want, right? They want us to enter the y-intercept. You know, so you give your answer as an ordered pair. Please read instructions carefully. So parentheses 0, 5. Right? Great. Okay. All right, so back to this one, where we're again finding the slope of a line given 2 points. So you write those 2 points out. Let's go here. So the points on this line are -2, 3, and -10, -4. Right. And again, slope is very simple in my opinion. Once you know 2 points on a line, you just, you know, the numerator, again, the numerator is a vertical change, the change in the y coordinates. -4 -3. And the denominator is a change, so I like putting the minus sign there sometimes ahead of time, in the x coordinates, but make sure you take that change in the same order. So I did right minus left, so you got to do -10 minus -2. And then we'll simplify. Now -4 minus 3, the numerator is -7. -10 minus -2 is -10 plus 2, which would be -8. Right, and this is a negative divided by a negative again, which would be positive. Right, positive 7/8, and that's as simplified as that fraction gets. And again, if you had drawn the thing out, if you had drawn a graph of the line going through these 2 points, it should have a positive slope. It should be going up to the right. Yeah, so this is just 7/8. Alright, back to this. Alright, so this one I'm going to write on paper. Right, another one where they tell us the slope of the line is 10, that's the m, and the y-intercept is at 8, crosses the y-axis at 0, 8. So that's the b. So the equation for the line would be, the rest of the line, and all the points on the line would be y equals 10x, right, the slope times x, plus 8, right, plus b, plus the y-intercept, or the y-coordinate of the y-intercept. And that's it for that one. Very, very simple. All right, so that objective's done. Let's move on. Finish up this slope of the line going through two points. All right, so this time, I'll just keep the same page up. Let's go over here. We're going through the points 6, 3, and -6, -3. Alright. So this is going to have a positive slope as well. I'm kind of picturing it in my mind. But we have m equals, right, slope equals, again, just the change in the y coordinates, -3 minus 3, divided by change in the x coordinates in the same order, -6 minus 6. Numerator is -6. The denominator is -12. Dividing negatives makes a positive. This is positive 1/2, right, when totally reduced, right? 6 and 12 have a common factor of 6. If I divide both of those by 6, you get 1/2, 1/2. So the slope of such a line going through those 2 points is positive 1/2. Great. All right, Next, this should be the last problem from this objective, and then we'll move into that other topic with the 4 objectives. So find the slope of the line through these 2 points. Now notice one of these is the y-intercept, 0, -6. So we have the b for y equals mx plus b. We just need the m, right? And we could actually write an equation for this line, but they're not asking for that, right? They're just asking for the slope. Right, so back to my paper. I'll just kind of use as much of this paper as I can here. So we're going through the points 7, -1, and 0, -6. So again, slope is pretty simple when you have 2 points. -6 minus -1. Right, change in y coordinates in the numerator, the rise. And then 0 minus 7 in the denominator, right, the change in the x coordinates. Now -7 minus -1 is -6. -6 minus -1 is +1. -6 plus 1, that'd be -5 in the numerator. 0 minus 7, -7 in the denominator, that's +5/7. Alright, so far all the examples we've seen have had a positive slope. You saw earlier, there are lines that will have negative slopes. Please understand this. Alright, so 5/7 is what I'm going to enter. Or a slope of 0, or a slope that's undefined if it's a vertical line, right? I talked about all that earlier. But 5/7. Alright, so that's it for that objective. So now we're moving into that other topic with the 4 objectives. Right. So we got these 4 objectives here under find linear equations. Right. And this is where we're going to start. We talked about slope-intercept form already. This we're going to be talking about other forms. There's point-slope form, and their standard form. Right. And they also have slope-intercept form again. Right. So before I get into this example, right, we're asked to, given the slope and intercept, find an equation of a line and write it in standard form. I want to talk about the different forms of a linear equation. All right, so we have slope-intercept form already. Right, y equals mx plus b, where m is the slope, b is the y-intercept or the y-coordinate of the y-intercept. Right, you got that down. All right, they're talking about standard form here. Standard form of a linear equation simply has all the variable terms on one side and constants on the other. So it looks like this: a times x plus b times y equals c. All right. Where a, b, and c are numbers, right, are real numbers. Now very often they might restrict them to being just integers. I've seen some texts where a, b, and c have to be integers, right? 1, 2, 3, 4, -1, 2, 3, 4, right? Those, no fractions. But I'm going to stick to just real numbers and let's see what happens. Right. Now, the other form. So again, this is easy to get, really. If you know an equation, like if I had y equals mx plus b, I would just subtract the x term, and then you'd be in standard form, right? The variable terms are on one side, and then the constants on the other. That's standard form for a linear equation. Pretty simple. Then the other form is called point-slope. And this is actually my favorite because I think it's the easiest one to write. So this is, given a point say x1, y1 on a line, and the slope m. Right, so say you know these two things. You know a point on the line, say x1, y1, or 1, 2, 2, 5. Say you know the coordinates of a single point, or more than one point, but just pick one, and the slope. Right? You know a point and the slope m. Well, then you can write the equation very simply as the change in y, so y minus this y coordinate, y1. So this y is a variable. All right, this is the variable y minus a number y1 equals slope times quantity change in x minus x1, where x and y are variables, right? X and y represent x and y coordinates for any point on the graph. x1, y1 are the coordinates of a single point, and m is the slope. And this really comes from the slope formula. Remember how slope was change in y divided by change in x? Well, if you multiply both sides by change in x, you get this equation here. The change in y equals the slope times change in x. All right, and we'll come across examples like that shortly. All right, so back to my problem here. All right, so we're asked to find the equation of a line that contains these points and write the equation in standard form. All right. Now this doesn't really match the objective. They said given slope and intercept. We don't have any intercepts here. We can find the slope easily, but we don't have the y-intercept. Right? So that's why point slope is going to be my favorite. All right. So for example, I will keep the point slope form up on the page. So here's a line. A line passes through the following points. -7, -4, and -2, 3. So first let's find the slope. Again, just change in y, 3 minus -4, divided by the change in x, -2 minus -7. This is 3 plus 4, that's 7 in the numerator. -2 plus 7 would be positive 5 in the denominator, right? So the slope is positive 7/5, and then you just pick any of these points. So I'll just take this one here, call this my point x1, y1. So now I know a point on the line, I know the slope of the line, so the equation for this line in point slope form is just simply y, right, the variable y, minus the y coordinate of the point that we picked. So y minus 3 equals the slope m, right, 7/5, times the quantity, right, make sure you're putting this in parentheses, and then the change in x. So it's again the variable x, unknown x, minus the known x, minus -2 or plus 2. Right? Nobody writes minus a -2 often, right? Minus -2 would be x plus 2. So this is a perfectly valid equation for this line, right? And you can also verify that -7, -4 satisfies the equation. Replace x with -7 and y with -4, and both sides should end up being -7, right? The left side would be -4 minus 3, that's -7. And then the right side, when x is -7, is, you'd have -5 in here, times 7/5 would be -7. You'd have -7 equals -7. This point is on this line. This satisfies this equation. But they did want us to write the equation in standard form, right? So now I just have to get this equation I have here to look like that, where the variable terms are on one side, constant on the other, and no parentheses, right? So we distribute, right, so again, this is in point slope form here. Just distribute this 7/5. So we have y minus 3 equals 7/5 times x plus, and then 7/5 times 2 would be 14/5. And then I get all the constants to one side, variables to the other, so I would subtract 7/5 x. So I have negative 7/5 x plus y equals, and then I would add 3. But remember, you need a common denominator when you add, right? 14/5 plus 3 would be 14/5 plus 15/5, right? 15 divided by 5 is 3. I get a common denominator, that's 29/5. And this should be good. Alright, this should be good. This is in this standard form, right? The x and y terms are on one side and constant on the other. It's just, nobody likes fractions all that much. So then I'll multiply both sides by the LCD, which is 5. Alright, multiply both sides by 5 here. And then I'll cancel all the 5s. So we have negative 7x plus 5y, right? I still have to multiply the second, we're distributing the 5 over here. Equals, and over here you just got 29. Right? And this is what I'm going to enter. Right? I personally like having integers, if possible. Right? If possible. Obviously, if pi or the square root of 2 was in here, some irrational number, you couldn't get integers as your coefficients. But here's what I'll enter. Standard form. So the equation of this line is negative 7 times x plus 5 times y equals 29. That should be good. And again, you can verify by checking to see if these points satisfy the equation. I'll just do negative 2, 3. If x were negative 2 and y were 3, you'd have 14 plus 15 equals 29. That's true. Right? And then the other one should work as well. You can check that on your own. Okay, I mean, they multiply both sides by negative 1 as well, but yeah. And again, please read through the answer explanations. All right. Next question. All right, so now we're finding the equation of a line in slope-intercept form, given the slope in one point. Okay, so I'll keep that point slope form up on screen. There it is. Now we're told the slope of this line is 5, right, positive 5. And we're told that a point on this line is the point 8, 5. Right. Now you could just keep using the definition of slope here to find the y-intercept, and then you can write it in slope-intercept form. Other points on this line would be the following. Remember what I said earlier, if the slope is 5, that means if I increase x by 1, y would have to increase by 5. You got 9, 10 would be on the line. But I want to go backwards. I want to get to an x coordinate of 0. So that means if you can increase x by 1 and then increase by 5, or decrease x by 1 and then you have to decrease by 5. So 7, 0, 6, negative 5, 5, negative 10, 4, negative 15, 3, negative 20. All these points would be on this line. 2, negative 25, 1, negative 30, and then 0, negative 35. And so the line is y equals 5x minus 35 there, right? Because I got the y-intercept. Right? There's the y-intercept right there, 0, negative 35, using the definition of slope. But that's annoying, right? That takes a while, especially if we're not that close to having x be 0. So an easier way would be to take my slope, take the point, right, and again I'll call this x1, y1, and then I write the equation in point slope form. Y minus 5, right, y minus y1 equals the slope 5 times the quantity x minus x1, x minus 8. So here's the equation of this line in point slope form, and then I want to get it in slope-intercept form. Right? And this is solving for y and simplifying. So I distribute the 5. So we got y minus 5 equals 5x minus 40. And then I would add 5 to both sides, and there we go. Y equals 5x minus 35. Much, much faster that way, in my opinion. And that's all we're asked to write, right? Write the answer in slope-intercept form. Y equals 5x minus 35. 35. Okay, submit. Hooray. Okay. Next question. All right, so new objective, find equation in slope-intercept form. So again, we're entering our answer in that y equals mx plus b form of a line passing through two given points. So again, this is really no harder than the last problem. You just have to find the slope first. There's only one little extra step. So the line passes through points -8, 5 and -6, 7. So the slope, no problem, right? 7 minus 5 in the numerator, change in y coordinates. And then -6 minus -8. Change in x coordinates in the denominator. So 2 in the numerator. And then -6 minus -8 would be +8. -6 plus 8 is 2 in the denominator. The slope is 1. The slope is 1. Alright, so I have the slope. Now I just pick a point. This one here, why not? Just pick a point. Again, if I call this x1, y1, or whatever. The equation for this line would be y minus 7. Right, y minus the y coordinate of some point I know equals the slope 1 times the quantity x minus -6 or x plus 6. Now I don't need the 1 times there, right? Anything times 1 is itself, so there's really no need for the parentheses. And then I would just add 7. Right, y equals x plus 13. There's the equation of this line in slope-intercept form, right? So the slope would be 1, right? We saw that already. The y-intercept would be 0, 13. But we're just asked to enter the equation. Y equals x plus 13. And you can verify too that both these points would be on this, right? If x were -8 and y were 5, you'd get 5 equals 5. It's true. If x were -6 and y were 7, you'd get 7 equals 7. True again. Right? Should satisfy the equation, all the points on it. Okay. All right, next, we're back to this one. Write it in standard form now. All right. So this one we're actually told, the slope and intercept, so I can write the equation in slope-intercept form right away. The slope is 2, and the y-intercept is the point 0, -1, right? So the value of b is -1. So y equals 2 times x, m times x, plus b, plus -1, minus 2x minus 1. And then I can just simply subtract 2x. -2x plus y equals -1. This is totally fine. This is in standard form right here. ax plus by equals c. And that's what I'll enter. So -2x plus y equals -1. Now they may have, just because they might not want negative numbers in front, they might have multiplied by -1 on both sides and got 2x minus y equals 1, but it's the same thing. Right. See, they got, they put the same thing. All right, great. Okay, back to this one. Again, the line passes through these 2 points. Again, write the equation in slope-intercept form. Y equals mx plus b. Now, pay attention, right? They already have the y equals part down, so you just have to enter the other side. So I'm just going to get rid of all the pages with the forms on it now. Let's do these. Alright, so this line passes through the point 6, -1, and the point 7, 8. So I have points, just pick one later. I just need the slope. So 8 minus -1, or 8 plus 1 in the numerator, 7 minus 6 in the denominator, change in x coordinates. That's 9. Alright, 9 divided by 1. So the slope of this line is 9. Then I'll write the equation in point slope form first. So here's the slope, and I'll just pick this point. It doesn't matter. 7, 8. So change in y minus 8, right, y minus that y coordinate, equals the slope, right, 9 times change in x minus 7, right, x minus that x coordinate. So this is a perfectly valid equation for the line, but they want it in, slope-intercept form. So I'm going to solve for y and simplify, right, distribute the 9 here, get y minus 8 equals 9x minus 63, and then I would add 8. Alright, so y equals 9x minus 55, and there you go. Right, the slope is 9. The y-intercept would be at -55, right? 0, -55. And again, you can verify by checking that the points we got here satisfy the equation. Right. 9 times 6 is 54, minus 55 is -1, right? And 9 times 7 is 63, minus 55 is 8. Right? So both points are on the line described by this equation. It looks like we did a good job there. Now again, they already have the y equals, so I'm just entering the other side, 9x minus 55. Pay attention. Wonderful. Alright, next. So here we're given a slope and a point, and again asked to write the equation in slope-intercept form. Solve for y, right? Y equals mx plus b. Alright, so the slope we're given is -5. And the point we're given is 2, -3. Alright, so the equation in point slope form would be y plus 3, right, y minus -3, y plus 3 equals the slope, right, -5 times the quantity x minus 2. There's point slope form for the equation of this line they're describing. Then I'll distribute the -5 over here. Got y plus 3 equals -5x plus 10. Right, -5 times -2 is positive 10. Subtract 3, y equals -5x, and then 10 minus 3 is positive 7. The y-intercept would be at the point 0, 7. Okay. Let's put that in. Now there's no y equals here, so I have to type it. Right? Y equals -5x plus 7. Great. Alright, next. Alright, so here we go. Getting to a new objective, vertical and horizontal lines. I've already discussed the slopes of these. Right, remember, the slope of a horizontal line is 0. and the y-coordinate never changes. The slope of a vertical line was undefined, and the x-coordinate never changes. Right? And they tell you right here, the equation of a horizontal line is y equals some number all the time, because the y-coordinate is always that number. The y-coordinate never changes. The equation of a vertical line is x equals some number a, right? X equals the same number all the time because the x-coordinate never changes, right? So these should be very simple. Look, this line, -8, -1, and -8, -7 are on the line. Right? -8, -1, and -8, -7. You see how they have the same x-coordinate? You know, if I go to graph it, you know, -8, -1, and -8, you know, -7. This is a vertical line going through these 2 points. And if you were to calculate the slope, right, the slope would be undefined because you'd be dividing by 0, right? The denominator in that slope formula would be 0. You can't divide by 0. Now, for a for a vertical line, right, the x-coordinate is always the same number. And here the x-coordinate is always -8. There's the equation representing all the points on this line. The x-coordinate is -8 and the y-coordinate can be whatever you want. Right. So back here, now they didn't put x equals, so we have to write it. X equals -8. There's the equation for the vertical line passing through those 2 points. Right, so another one. Now here again, I'm not even going to draw this one. 5, 3. 5, -6, they have the same x-coordinate. So this is going to be another vertical line, and it's x equals 5, right? X equals 5 for all these points. It's that easy. Has an undefined slope. So now we're back to non-vertical and horizontal lines. Right? So here the slope is -2, passes through the point 7, -1. You know, write the answer in slope-intercept form. Right, so once again, I'll write this out. So slope is -2. The point that we're passing through is 7, -1. Again, you can draw it if you want, but the point slope form would be y plus 1 equals -2 times x minus 7. Right. Hopefully you understand that now. Distribute the -2. Y plus 1 equals -2x plus 14. And then subtract 1. Y equals -2x plus 13. There's your y equals mx plus b, the slope-intercept form for the equation of the line that they're describing. Okay. So that's what I'll enter. And they don't have the y equals, right? So I have to enter that. Y equals -2x plus 13. Right. All right, next question. Same kind of problem. Looks like we're going to finish this objective off with this one. So again, slope is +2. Same page here. Slope is +2. And the point we're passing through is 7, -9. So point slope form be y plus 9, right? Y minus -9 equals 2 times the quantity x minus 7. Distribute the 2. Y plus 9 equals 2x minus 14. And then I would subtract 9. Y equals 2x minus 23. There's the slope-intercept form. I'm hoping this isn't coming across as something that's too complicated anymore. Great, so that objective's done. And now we're back to the vertical and horizontal lines again. Look at these 2 points. They have the same x-coordinate. So this is another vertical line being described here. Undefined slope. And the equation is simply x always equals -4, right, for these points. Cool. Maybe they'll have a horizontal line. We'll see. Here's a horizontal line. Now remember, a horizontal line has a slope of 0. M equals 0. And the equation is y equals the same number all the time. Right? Every single one of these points on this graph has a y-coordinate of -7. Right? There's 0, -7, 1, -7, 2, -7, 3, -7, and so on. So it's just simply y equals -7. Now you could put this in slope-intercept form too. You know, y equals 0x minus 7. But that's just oh, pardon me. Wow. Sorry about that. But 0x means nothing, right? So just -7 would be left. Right, so that objective's done. Alright, now we're back to, here's a couple points. Write the equation of this line in that standard form, right? The ax plus by equals c. And I'm going to have a, b, and c be integers. So I'll get rid of the fractions if there are any. Okay, so I'm just keeping the same paper, why not? So the points that this line is going through is 1, -6, and -8, -1. So let me find the slope, right? You might have noticed that for all these equations, you know, to find the equation of a line, I need the slope somehow. Right. So -1 minus -6, that's -1 plus 6 in the numerator. And then -8 minus 1, change in x coordinates in the denominator. So that's 5 in the numerator, -9 in the denominator. So this is -5/9. The slope is -5/9. And then I'll just pick a point there. I'll use the point 1, -6. So the point slope form would be y plus 6, right? Y minus -6 equals -5/9 times the quantity x minus 1, right? Using the x coordinate from the point I chose. Now, if you don't want the denominator of 9 here, just multiply both sides by 9. Let's do that right now. That way the 9 will cancel over here, and distributing the 9 over here, you got 9y plus 54 equals, and then I distribute the -5 over here, right after the 9's cancel. That'd be -5x plus 5. And then I'll take the x term to the left. I'll add 5x. We have 5x plus 9y. And I'm going to subtract 54. 5 minus 54 would be -49. And there's your equation in standard form with integer coefficients. And again, just double check, you know, that these points actually satisfy the equation. Right? Replace the x and y coordinates and see if you get -49 equals -49. And you should, all right? But I'm going to leave the checking to you. 5x plus 9y equals -49. Great. All right, read through your answer explanations, right, and continuing on. So one more like this, where we're given 2 points on the line. Asked to write the equation of that line in that standard form, that ax plus by equals c. And again, I'm going to have a, b, and c be integers. All right, so let's go to my paper. No, let's do it here. There's plenty of space. So the points that they're passing through are 1, 4, and negative 3, 7. Alright, so the slope of this line, 7 minus 4 in the numerator, negative 3 minus 1 in the denominator, that's 3 divided by negative 4, that's negative 3/4. Alright, the slope of this line is negative 3/4. And then I'll just pick this point here, and the equation would be y minus 4 equals negative 3/4 times x minus 1 in parentheses. I'm going to multiply both sides by 4, so we have 4y minus 16, then the 4 cancels here, and distribute the negative 3 of negative 3x plus 3. Then add the 3x, got 3x plus 4y on the left. Then I would add 16 equals 19 on the right. Just make sure that both these ordered pairs satisfy this equation before you enter it. Do the checking on your own. Alright, so 3x plus 4y equals 19. Wonderful. Alright, so that objective's done. I got just one more to finish. Sorry about the length of this, but there's 6 objectives. Alright, now we're just writing equations in slope-intercept form instead. Alright, so solve for y and simplify, right? So again, I'm going to start off, I know there's no more room on this page. So the points our line is passing through this time is negative 6, 4, and negative 5, negative 10. So again, I need the slope. Right? Slope is negative 10 minus 4 divided by negative 5 minus negative 6, or negative 5 plus 6. So the slope is negative 14. It's negative 14 over 1. And then just picking, I'll pick this point this time, the second point. So the equation in point slope form would be y plus 10 equals negative 14 times the quantity x plus 5, or y minus negative 10, x minus negative 5. Distribute the negative 14, get y plus 10 equals negative 14x, and 14 times 5 is 70, negative 70. And then I subtract 10 to get y alone. Y equals negative 14x minus 80. There you go. And again, just verify, make sure both these ordered pairs actually satisfy the equation you're writing. But, I know I did it right. So negative 14x minus 80. Okay, submit. Great. Should have just one more like this, and then we'll be done. So yeah, 2 points. Oh, look at this though. Look at this though. One of these points is the y-intercept, finally. Alright, so I don't need to do that point slope form stuff. I'll find the slope, and then I know the y-intercept, so I'll have b as well for the y equals mx plus b. Alright, so this one, we have the points where our line is passing through the points negative 2, 7 and 0, 5. So again, the 5 will be b for the y equals mx plus b. I just need m. So 5 minus 7 in the numerator, change in y. 0 minus negative 2, or 0 plus 2 in the denominator. So that's negative 2 in the numerator, positive 2 in the denominator. The slope is negative 1. So y equals negative 1x, or just negative x, plus 5. Right? I don't need to do the point slope form stuff because I know the y-intercept, right? I have it. It's right here. When the x coordinate is 0, that's your y-intercept. And there we go. Well, that's what we're asked to enter, the point slope-intercept form of the equation. Now notice again they already have the y equals part, so I just need to enter the other side, negative x plus 5. And that should satisfy both these points. Both these points should satisfy the equation. We're looking good. Great. Alright, and that should be it for this preview version of this assignment. And as I mentioned at the top of the video, the questions I saw in this video may not be exactly the same questions you'll see when you're working on the assignment yourself. But, you know, all the objectives are the same, so the questions should be similar, and the way you work on them should be similar to the way I've done. So I'm hoping that watching me do these here will help you in some way, you know, when you're working on this assignment yourself. And thank you very much for watching.